Hello, we're out at IDF. I'm Josh Hilliker. I'm a client guy, and it was time for me to go talk to the server guys and figure out what's going on. So I'm here, my buddy Todd Christ, and
hey
Todd is at the Energy Efficient Data Center Power Management with Windows Server 2008 Hyper-V and Intel Dynamic Power Technologies. Wow.
It's a lot to say, isn't it?
It is. So Todd, show me what is this all about?
All right,
educate me.
Excellent. So obviously one of Intel's big proponents this year is to showcase power efficiency and power management. And what we're trying to show is the power of Xeon platforms. In Xeon platforms, most notably, we have our Starlake platforms over here in this rack. We have 4 servers that are running. They're all running Harpertown processors. They also have a component inside called Node Manager. And Node Manager is a policy-based monitoring device where we can send remote controls to that device, monitor what power utilization is going on in the servers. So it's kind of takes that vPro sense in the client space and it's extending it into the server space where you can do some remote management. Now up here on the screen, we have our data center manager, which is basically a graphical implementation of our SDK. And what it's doing is it's measuring the power across these 4 servers up here on the screen. So as I click through each one, you can see it'll show you the power usage on each of the machines. As it does a simple refresh, you'll see that this server right here is using a little bit over 250 watts at its peak power, and whenever we drop it down, right now it's in idle state, and it's using about 175 watts just idling. Now, what I want to talk about a little bit is we have Windows Server 2008 running on the servers, and here's a screenshot of what's actually running over on one of the systems over here. It's running Hyper-V, and within Hyper-V, we're running actually 4 VMs. They're all running Windows Server 2008 within each of the VMs. And right now you can see, if you can zoom in on that, it's all 0% CPU utilization.
Okay.
So what I want to do is come over here and place a load on these. We have this little app that'll send a command out to all the servers. And what I'll do is I'll bump this up to 100%. And the workload that we have on these machines is a spec power load. And most people know spec as one of the most notable benchmarking and testing allocations
Here we go.
that we have out there. So as you can see, these all have now bumped up. They'll jump up, and you'll see them throttle up and down, but they'll throttle around 20 to 25%. A little bit of overhead goes to the OS, but these machines are running at a full 100%. And here, I'll minimize this guy over here, and we should start to see a spike in the power as that performance jumps up. So all that so far, nothing new, right? You put a load on the server, power utilization goes up, the processor P states go up to meet that performance level. So you're running these Harpertowns at the maximum P state that they can run at. So as we'll see in this refresh, just to talk before, we're 942 watts for all 4 servers, and then whenever we had put these back to sleep, 643 watts. So, and I can go in through Data Center Manager, and there's all kinds of different features that can be set and how we can do the trending and make these things look. And as the power is coming up and monitoring, I'll show you can also do policies on how you can rate limit the max power that you want to place on the rack. Now, this is the beauty of the Data Center Manager and how it works with Node Manager, is that it looks at the workload on each of the servers, and it monitors that workload and says, how much CPU utilization are you using? How much headroom do I have for this entire rack? So for these 4 servers, we can go in and we can put policy caps on there. So as you can see, the power is going up. As I start to go up here, 733, the next measurement, if I can get on that little dot. Oh, I was right on it. So 869. So you can see that power is definitely climbing as this workload is processing through. There's 16 VMs, so there's 4 VMs per server. So we've got 16 workloads running across these 4 servers. So we've got a lot of extra energy going on right now. So what I want to do is I want to cap this power, right? So say I have a power budget, and once this workload gets all the way up, it's going to go to about 942 watts, and that's a lot of power to expend, right? I mean, that's a lot of extra burn. 942 down to idle of 643. So I mean, we're talking 300 watts of power. That's a lot of extra money that you're spending. And this is only on 4 servers. Take this to 100 or 1,000 servers, and you have a very exponential number of power that you're spending. So we can go in here and set a power policy, And we'll set the power cap, and I'll say I only want this to use 900 watts maximum. So, and you can change this. There's all kinds of time settings you can put in there. So for after hours, you want to crank it way down and minimize it. You know, nobody's in using the office applications, nobody's using the workloads. You can crank it way down and save a lot of extra power. So as we'll see this on the refresh, you'll see that there will be a power capping mechanism that comes into play here. And what it's actually doing is it's sending commands back and forth to the servers from the data center manager, talking to the node manager components in the Xeon platforms. And it's saying, hey, how much power are you utilizing? I have a power cap now that I have to spread across the 4 different servers that are out there. So it's looking at the workload on each of the 4 different servers, and it's throttling down their P states, performance states, on the CPUs to keep maximum performance for the processing power that it needs to run these VMs and the workloads, but it's also reducing that P state to also save some energy. Because whenever you reduce that P state, you're reducing voltage, you're reducing all the extra energy that's utilized. So as you can see in here, as the power is changing, here's our requested power policy at 900 watts. You know, we had popped back up here to 942 watts again, and here comes this power policy again. Okay, so I changed the policy window to show a 2-hour time frame now, and I've updated the refresh to be every 15 seconds. So now you can actually see these updates a little bit quicker. So from 942 watts, and you can see that we've dropped down. You can see this yellow line is now dropped down. It's at 910. And what it's doing is it's still monitoring those workloads, and it's judging that power utilization line to get it down to that 900 watt request level that we've wanted. So you can see right there, requested power policy 900, 942. So right there we've saved 42 watts in just utilizing this application and having Node Manager perform the functions on the Xeon platform to change the P states and reduce the power utilization on these CPUs.
Wow, impressive.
Some pretty cool stuff, and I'm hoping for on the Expert Center, probably within the next month or so, hope to get something that shows Tylersburg with Nehalem CPUs in it, because it even broadens the scope even more moving forward.
Awesome. Thank you, Todd.
You're welcome.
And that's it about the Data Center Manager and Node Manager. Thank you all.